All right, so we have to graph this square root function. As soon as we see that it is a square root function, that tells us which values we're going to start off with. So what values am I going to use?
Y's.
Like, say the numbers I'm going to put on this chart right now.
0, 9,
Right, and 16, but this is a really tiny graph, so I'm just going to go with this. Of course, if I take the square root of these, I'm going to get 0, 1, 2, and 3. Now, what makes this problem special is it has this -2, but instead of being in front, if that -2 were in the front, if it were out here, I would make a new y column, and I'd multiply everything by -2. What do I do when I have the -2 underneath the radical like that? Go. You do the x instead of y. So when you have a new number on the inside, you make a new x column. All right? So watch this. Boom. Okay, we're going to make a new x column. Now let me ask you this. Am I going to do -2x the same way I usually do -2y? Okay. I will not do just -2 because a -2 in the front would be a vertical stretch by a factor of 2, but a -2 on the inside is a horizontal compression. So because it's a compression, I need to do 1/2 instead of 2, -1/2. So that's going to give me 0 and -0.5 and -2 and -4.5. Any questions about where I'm getting these values from? So I've got a new x column, so skirt, I'm going to throw out the old x column. So we plot these points and treat it like the parent function. Okay, let me zoom in a little bit. Okay, so 0, 0, -0.5, comma 1, -2, comma 2, and -4.5, comma 3. Okay, don't connect those, but those are mandatory. Those dots need to be there. Now, where am I going to move those 4 points? What do I do now? Left 1 up 2. All right, so I'm just going to take each one of these 4 points, and I'm going to move them left 1 up 2. Left 1 up 2. Left 1 up 2. And left 1 up. Whoops, I messed up. Try that again. Left 1 up 2. All right, so the pink dots show you where the final answer is going to be. All right, so it should be swerving to the left like this. So there's an arrow on the left, and it ends there at the point. What's the ordered pair for this starting point?
-1.
Just blurt it out. Go. -1, comma 2. So that's what's meant by the starting point. So -1, comma 2 is the starting point. Now, give me a thumbs up if you think that that graph is increasing. Give me a thumbs down if you feel like it's decreasing. So is it increasing or is that a decreasing graph? You can see everybody's thumb real quick. Okay. All right, put them down. That was a lot better than my other class. They were all mixed. It was like they could have just been guessing. Almost everybody said that this is decreasing. The key is that you have to read it from left to right. And from left to right, you can see it is going downhill, so it's definitely going to be decreasing. I'll just circle it. Okay, now the domain. Somebody I haven't called on yet. Who wants to take a shot at saying the domain? All right, Cheslin, give it a shot.
Parentheses, -infinity, and then -1 with a bracket.
Perfect. This graph, you have to go from left to right, like Cheslin said. And from the left, it's at -infinity. It goes to the left forever. So that was good. So -infinity. And then to the right, it stops at an x value of -1. So negative infinity to -1. All right, Sarah Post, did you want to give the range a try?
Yes, I'm gonna say negative infinity to 2.
That is close, okay?
Hate myself. I mean, negative infinity to 2.
Okay. So the
Here's 2.
just remember to go in the
To
order
infinity.
from bottom to top.
Right.
Okay? So if I trace this out on the x-axis, why is that so big? I hear you saying that it starts here at 2,
Yeah.
and then it goes up from there.
Yeah.
So that's 2 to positive infinity.
Yeah.
Okay, so that's my range. Bracket 2 to infinity. Any questions on that?
I have a question.
Go.
Why is it not a negative infinity, but it's a positive infinity? Because it's decreasing, so wouldn't it be going from negative infinity to negative?
So you're talking about specifically with the range in this case? Okay. So remember, when you're talking about these infinities, there are 4 infinities floating around this graph. All right? I'm going to put an infinity right here. What kind of infinity am I going to put up there? That's positive infinity. Okay? What kind of infinity am I going to put here? Negative infinity, because it's to the left. Okay? What about down here? That's negative infinity. And what about over here? That's positive infinity. So I have 2 positive infinities and 2 negative infinities. When I'm doing the range, which 2 infinities am I looking at? I'm looking at, remember, does range go up and down like this, or does it go side to side like this? Right, range goes up and down. So when I'm doing the range, I'm looking at this infinity and I'm looking at this infinity. Okay? So that's why when you're tempted to say negative infinity, you're looking at this left negative infinity. Okay? But it's going upward towards that positive infinity. Okay, now the last little part, the end behavior. End behavior always has 2 parts to it. This is for the left side of the graph, whatever's happening on the left. And then this will be for whatever's going on the right side of the graph. Okay, so let's start with the left side. So when I talk about the left side, I'm talking about this. I'm sort of looking at this arrow right there. So as the x values go to the left, how far to the left do these x values go? They go forever. So as the x values go to the left, go to negative infinity, now I'm asking what the y values do. So as I'm traveling to the left, what are the y values doing? Positive infinity, because as I go left, it's going up. All right, as I go from this point towards the end, as I'm going left and I'm going up. So as I go left, I'm going up. So as the x values go towards negative infinity, the y values go towards positive infinity. All right, I feel like a couple people are confused by that. Raise your hand if I lost you just now. You're okay?
What was
All right.
the answer?
It's still here.
No. Oh, I thought you were on the right.
Okay, now looking at the right-hand side, because this is a little bit different than what we're used to because of the way it ends abruptly. If I look at the right-hand side, I'm talking about this dead end. It doesn't go to the right forever, so I'm not going to say anything about infinity. Okay? So instead of saying as x approaches infinity, what x value does the graph approach? It approaches -1. In fact, look at this. Look at the starting point. All right? You see there's your x and there's your y. Basically, I'm just about to mention those 2 coordinates. All right? So as the x values approach -1, then what do the y values approach? 2. Okay? It's the y value of that starting point. So that's what you do when it has a dead end like that. You just put the coordinates of the starting point. All right? Did I write this whole thing?
Yeah, you were on the wrong spot.
Did I write in the wrong spot?
But I didn't
All right,
know
we
that,
get it.
so.
Yeah, that was wrong. Skirt. Any questions about number 6 there? All right, let's go on to the lesson.